So this is the air tunnel, and we get our data on the screen here, and then we got some values up here. Now we're at the actual wind tunnel. We can feel the air. So this is our lab report for laboratory exercise number 3, wind tunnel testing of the NACA 2412 airfoil. And these were my partners, myself, Anna Nichols, Lauren Dickinson, and Nate Allwine, Vi Hang Sandayak, and our lab instructor was Cameron. The goal of this lab was to understand the software associated with the wind tunnel, as well as analyze the data collected for the wind tunnel simulation. An airfoil was introduced and studied in the wind tunnel, and it was modeled and simulated in XLR5, which is a computer program to analyze airfoils. Inputs to the XLR5 software were found through calculations, and the resulting model was compared to the data gathered from the airfoil in the wind tunnel. So these were our calculations. We found the Reynolds number, which will tell us how the air is going to flow, and then we found the air speed in Mach, which is the almost speed of sound that you're going, so the percentage of speed of sound that we're going. And these are our charts for the real wind tunnel. These are the computational ones, but I wanted to show you the comparison, which is in real life our model was much more subtle. The lift values were lower than the wind tunnel, and in the analysis there was a lot more of a rush upwards with the lift coefficient, and then it stalled, where in our wind tunnel that did not happen. So there must have been some difference between the two. And then if we look, the coefficient of drag and coefficient of lift were different, as in this one we had much higher drag in the wind tunnel with lower lift. And this is at 15 pounds per square foot. We tested it in 2 environments, the 5 pounds per square foot wind pressure and 15 pounds per square foot wind pressure. So this one was at a much higher wind speed, and our data still did not match exactly. So we found out that in the end they were similar, but there was a much different amount of lift generated between the two models.